Welcome! In this demo, we'll show you how we built a framework that turns API definitions into fully working frontends. Modern software increasingly follows an API-first approach, designing APIs before the actual implementation. This improves collaboration across teams and accelerates development cycles. Standards like OpenAPI make this possible by describing RESTful APIs in a machine-readable way, enabling tools for documentation, testing, and SDK generation. But here's the catch. Even with structured API definitions, building frontends is still a highly manual task. Developers must repeatedly create forms, manage authentication, and style pages from scratch, every time an API is updated. While there are tools that try to generate front-end code from APIs, most of them fall short in real-world use. They typically produce boilerplate or basic scaffolding, but you still have to manually write the logic and adjust the layout. They don't support flexible customization. Things like layout structure, styles, or component behavior are often missing. And many of them only generate the API client logic, completely ignoring the actual user interface. APIs don't just expose back-end logic. They already describe key elements like data models, endpoints, and authentication scopes. So the question is, why stop at back-end code? Our idea is to take this structured information and use it to generate fully functional, customizable user interfaces automatically. Our main objective is to develop a framework that generates complete React-based frontends from OpenAPI specifications. It supports full CRUD operations, authentication and authorization, and layout-level customization. We also evaluate the usability and performance of both the framework and the generated frontends. Let's start by looking at what drives our UI generation. Everything begins with the OpenAPI specification. We read endpoints, schemas, and authentication scopes, and we also support helpful extensions like display names and role restrictions to enhance the UI behavior. To generate a fully functional frontend, we need more than just an OpenAPI spec. OpenAPI defines endpoints, but not how to organize screens or navigate between them. Simple page mappings, like this example, also fall short. They don't define how content is rendered or how to handle static elements. That's why our framework uses a component-based page configuration file. Each page is structured using root and result components, giving full control over layout and interaction. This makes the generated UI more meaningful, modular, and customizable. This slide outlines the components supported in the page configuration file. The tables detail the properties each component accepts, the result components they can have, and their nesting capabilities within other components. This is the high-level architecture of the framework. It outlines how parsers, handlers, populators, and generators work together to transform user inputs into front-end code. This diagram explains how populators work. Each component type has a specific populator that defines its role and behavior. Populators are switched dynamically based on the component type. The framework also provides multiple levels of styling control. You can apply global styles across all components, like tables or cards, use per-page JavaScript styles, or even fine-tune layout and spacing using styled wrappers. This makes the generated frontend both consistent and highly customizable. Now let's walk through how the framework works, starting from setting it up, all the way to generating a functional frontend. Let's take a quick look at how the framework performs and how well the generated frontends hold up in real usage. This evaluation looks at how efficiently the framework handles front-end generation. For a 10-page UI, the entire generation takes around 1.5 seconds. Even at 100 pages, it stays around 3 seconds, with a near-linear time increase. CPU and memory usage also scale predictably. A 50-page front-end consumes under 17 megabytes, indicating the framework is lightweight and scalable. Once generated, the front-end was tested using Google Lighthouse. Metrics like first contentful paint, layout shift, and time to interactive all fell within acceptable thresholds. This indicates a fast and responsive user experience, with minimal layout shifts and smooth interaction. To evaluate how user-friendly the framework is, a usability study was conducted among 15 users with diverse levels of front-end development experience. The system usability scale was used, consisting of 10 standardized statements. The framework achieved a SUS score of 72.67, indicating good overall usability. Feedback was also gathered on the quality of the front-ends generated by the framework. Participants rated aspects like UI clarity, routing correctness, and overall responsiveness. Average scores were consistently above 3.2 out of 4. You can access the complete project, along with documentation and released versions, through our GitHub repository. Feel free to explore and try it out.